The graph below shows the pulse rate of some gym members before and after exercise. Now I'm just going to draw your attention to the key here. So this is the value in the stem. This is a leaf that's to the left, so in this data set here, and this is a leaf that's to the right. So when we look at the left data set, we just look at the stem and the leaf, and that represents 82. And when we look at the data set to the right, we look at the stem and the leaf, and that represents 86, and that's what this is saying here. We want to describe the shape of the distribution of each of the data sets. Well, if we look at them, they both appear to be negatively skewed. Most of the data is at the bottom end, and then it stretches out. So they're both negatively skewed, but the before seems to be to the left or contain lower values than the after. So that's what I would comment on. Determine if outliers exist for either data set. So let's look at how much data is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 add 1 divided by 2 gives me 10. The 10th piece of data is the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one here is the median. So the median is equal to 76. And then there'll be 9 pieces of data either side. 9 plus 1 divided by 2 is 5. So the 5th piece of data, 1, 2, 3, 4, 5, is the lower quartile. And after the median, 1, 2, 3, 4, 5. So the lower quartile is 70, and the upper quartile is 88, giving us an interquartile range of 18. And all of that was for the before. And if we do the same for the after, let's just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we suspected there'd be 19 because these are the same people, but I just thought I'd check. So the 10th piece of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was the 98 here. So the median is 98. Let's find the lower quartile and the upper quartile. So 1, 2, 3, 4, 5. Lower quartile is 90. 1, 2, 3, 4, 5, and then 104. So we've got 90 and 104, giving us an interquartile range of 14. So this is the information for after. Now note here that this is precisely the sort of scruffy working that I would probably tell you about, but I've got limited space here, so I can't lay things out as nicely as I'd like to. So, outliers. So if we look at the before data, and we do the lower quartile, take away 1.5 times the interquartile range, and also we need to do the upper quartile, add 1.5 times the interquartile range. So let's see what those give me. So I need to go back to main. Let's just clear all the previous calculations I've got there. And I'll do 70, take away 1.5 multiplied by 18. That gives me 43. We certainly didn't have any data lower than that. And then we've got 88 add 1.5 multiplied by 18. That gives me 115. And we can see that the highest data value here is actually 110. So no outliers for the before. Let's look at the after. So lower quartile, so we'll go 90, take away 1.5 times 14. And we also need to do the upper quartile, 104, add 1.5 times 14. So 90, take away 1.5 multiplied by 14, gives us 69. We don't have any data that low. And then we'll do 104 add 1.5 multiplied by 14. That gives me 125. And we do have this one piece of data out here of 146. So 146 is an outlier. Hence determine and calculate the most appropriate summary statistics to represent the data. So because we know the data is skew, and this one's not only skew but it's got an outlier, the median and the interquartile range are going to be the best statistics in all likelihood. The mean and standard deviation using all the data values can be affected by the skewness and certainly by outliers. Compare each of the statistics calculated in C in the context of the question. So we had before and we had after, and we know that the median here is 76 and the interquartile range was 18. After, we had a median of 98 and an interquartile range of 14. So we'd already calculated these statistics, obviously. So in the context of the question, well, this is to do with pulse rates before and after exercise, so we must talk about that. So the median pulse rate before exercise is lower than the median pulse rate after exercise. So that's a comment about the average or the middle of the data. Then we should talk about the spread, and we can say that there was a slightly greater range of values, or interquartile rate, so a slightly greater dispersion of the rates before exercise. However, if you use the range, you'll probably find there's a bigger spread here. And that's the sort of thing I would calculate and mention. We're now asked to write a report comparing the data sets. Well, I'm not actually going to do that, but what should we put in a report? Well, we should put in what exactly we're measuring, so it's pulse rate before and after exercise. We should mention the things we mentioned in D, so comparison of medians, comparison of interquartile range, and I would say also comparison of range here, since it seems to have a very big effect with this outlier out here. I would also talk about the shapes of the distribution, the fact that they're negatively skewed, and then you would want to conclude, and that would be as simple as, the data shows that during exercise the pulse rate increases.